Alright, you guys. So in day 18, we have managed to escape the cave system, but we are staying hidden because the volcano is actively erupting and we don't want to be hit by some lava. And I guess since we have nothing better to do, we want to again simulate some stuff. So the idea is that when some of these lava droplets fall into the river or into the water around us, they will solidify into a cube shape, and we can scan these shapes into a 3D grid, and the resolution will be pretty bad, so we'll have like one by one by one cubes, but we know that these cubes will form a rock from the lava. So we will get as input the list of cubes that form this rock. So we'll get the coordinates of the center of each cube, I guess. And what we want to calculate is the number of faces that are unique. So basically the faces that are not touching other cubes. Then for the second part, it seems like there are some air pockets inside this rock. So counting the number of faces that are unique isn't enough. We want to do some Minecraft rendering stuff where we count only the faces that are showed to the outside and do not count the faces that are inside the rock. So for the solution of this problem, I created this structure called point, and I was thinking to use this as the center of each cube in the rock. Then reading a line and converting it into a point was pretty easy because we just have to split the line into integers by comma. So yeah, pretty easy. Then for the solution, I implemented these two helper methods. The first one called neighbors, and this method will take a point and it will return all its neighbors. Like there will be six neighbors, one up, one down, one in the front, one in the back, one to the right, and one to the left. And yeah, basically I did this because these are the only neighbors that can have a common face with the current point. Then for the second part, I have this bounded helper method because as you'll see, we have to check all the points inside the bounding box for the second part, or that's the easiest way to do it. Okay, so for the first question, we have all the points in the input and we compute all the neighbors of these points and we flat map them together. So this is basically in some way we extrude outwards with one step all the cubes, and after that we filter out all the points that are already in the input. So basically we remove the insides of this new shape, and this will give us the blanket over the rock and over the insides of the empty pockets of air from the inside of the rock. And yeah, if we count everything, we get the total number of faces, like the entire surface of the rock. For the second part, we compute the maximum value of these points. So that will be like the after that point we don't care anymore what happens next because the rock is complete, like you won't find anything else after that. Then we have to do some kind of search algorithm, like for example BFS, and we start from the point 0, 0, 0. Then we have to go through all the neighbors of this current point, and if the point is not already visited or it's not contained by the input points and it is also bounded, we can visit that point and put it in the queue. Then at the end we do a similar thing as before. We generate all the neighbors, but this time we are interested only in the nodes that are inside the visited container. Basically this is very similar to the first solution, but instead of getting the points that are also on the inside, we only get the points that are on the outside of the shape, because this float fill algorithm won't be able to get inside the rock. We'll just move on the outside of the rock. And yeah, then to get the solution, we just count the number of these type of points. So yeah, this was the day 18. It wasn't that difficult, but yeah, I mean it's good that it was easier because the other 2 days from before were more complicated. So yeah, it was pretty cool nonetheless. So if you want to check the code, you can find it in the description, and see you guys next time.